Welcome back, ladies and gentlemen. We are looking at day 2 of the Unit 1 practice test review. Let's get into it. Explain and show. So they want words to explain and work to show how to find the period of the function f of x shown in the graph. So they're calling this function f of x and they want the period. Well, we can visually see, we can go mid to mid, max to max, or min to min, right? So I always like to start with the y-intercept because we're counting x values, right? And 0 is the easiest thing to count from. So max to max, that's going to be the period length, which we see is 2 pi over 3. Now here's a little explanation with that. Period is a distance on the x-axis that it takes to go from max to max. Well, that's basically what I just said. So there it is typed out, and there's a visual. Remember, no matter how simple a question is in a practice test review, you always have to show work and an answer in order to get credit. It doesn't have to be right. It's in your best interest that it's correct, and you can get that correct right here by watching these recordings and following along. Okay, number 8. Explain and show how to graph the function you see. There's not a ton of transformations here. How many do you see? I see 2. I see a negative, meaning it's a reflection over the x-axis, and I see 4, meaning the amplitude is 4. Okay, so what I'm going to do is just graph a parent sine function, which does span from 0 to 2 pi, and a parent sine function has an amplitude of 1. It travels a distance from 0 to 2 pi, and it goes up first. So it would go up to here, up to the max, down to the mid, down further to the min, and then up to the mid. That's the parent function. And I drew that so you can see the changes. Okay? The first change is that there's a reflection over the x-axis. So the max here flips now. It's going to flip upside down. This goes there and that goes there. Now you're going to have a line that looks like this. Okay? That's the first transformation. Oh, I think I removed too much. Let's put that back. I want the negative line there. There it is. Cool, cool. And now the amplitude needs to be stretched by a factor of 4. So a factor of 4 means, okay, here, let's focus on this one. Here the amplitude was just 1. But a factor is something you're multiplying by, right? And we see that 4 right there. So you're multiplying your amplitude times 4. So it was 1, but now it's going to span up 4. Same thing from mid to min. So I'm going to clean this up and just get rid of the additional things I drew. Take us back to our final graph here. Looks like I need to erase just a bit. There we go. That's what it looks like. There's some explanation added on the side where you can explain in your own words. And you could use your spacer and all that stuff, but I mean, we know the parent function is 0 to 2 pi, and since there's no adjustments to the period, right? B is just 1, then we're not horizontally stretching or compressing. Number 9, explain and show how to graph this function. A lot of explain and show today. It's good practice. If you see both these symbols, don't let them throw you off. You have pi x over 3. Remember, x is the variable, pi is a number, it's 3.14 and many more decimal places. So what would b be? Well, you can put the x at the end, so b is pi over 3. We're going to use that to graph and explain this because really that's the only transformation. There's nothing changing over here. A is 1, m is 0, so midline's at y equals 0. A is 1, amplitude is 1, mid to max, mid to min. B changed though, so we need to um, show what B is and plug it into our period formula because that's how we graph it, right? We don't graph B, we graph P. So that pi over 3 goes there. Once again, keep, change, flip. Pi's cancel out to give you 2 times 3. Okay, so period is 6. Great. We know the last point is there, but what are our spacers? Take that p, divide it by 4, you get 3 halves or 1.5. So every time you go over 1.5, you have another critical point. Max, mid, or min. And by now you should definitely know that a positive sign function has the y-intercept at the midline and it starts by going up. Number 10. In the function f of x equals cosine x, the parent function of cosine, f of x is multiplied by a factor of 3. Okay, x is replaced with 4x and 5 is added to the function. So what are they doing here? They're explaining in words what the transformed function looks like, but we need to actually put it together. So explain the effects this has on the graph of the function. Oh, interesting. So they're not asking us to graph and they're not asking us to write the new function. What they're really asking is, are there horizontal or vertical stretches and compressions? Are there shifts? In which direction? Are there reflections? All of those types of things. Well, if it's multiplied by a factor of 3, that means this will be vertically stretched by a factor of 3. If x is replaced with 4x, that means b is now 4. And remember, that means there is a horizontal compression of the reciprocal of 4. Okay? So this means each period length is 1/4 of what it was before the compression. Okay, since b equals 4, that means 4 periods will happen between 0 and 2 pi instead of just 1. So they're all scrunched in together, right? We're saying one period was like this. This is a actually positive cosine, so max to max from the y-intercept. And we're basically saying, okay, from here to, let's just put the x-axis there. Why not? We're saying the initial period was 2 pi. And now we're saying there are 4 periods happening between 0 and 2 pi, so this is going to be compressed quite a bit, really squished together, so there's 4 periods in there. And finally, 5 is added to the function. We always see that at the end. That means there's a vertical shift up by 5 units. And what does that do? Well, that moves the midline as well as every other point. So the new midline equation is y equals 5. 2 more to go. You're so close. Stay focused. Here we go. Visualizing you're at the beach, you're at the ocean, you're at the dock on the East Coast. I know we're on the West Coast, but you get the idea. Low tide occurs at 3 p.m. Low tide occurs at 3 p.m. with a water depth Water depth of 5 feet. Okay, so maybe we want to label some of that. So 3 p.m., 5 feet. Maybe not that. We might think that's a minus sign. 3 p.m., 5 feet. The depth at high tide, 83 feet. And that occurs every 6 hours. Okay, so 83 feet every 6 hours. So this information is connected and this information is connected, and all of it ultimately is connected in the bigger picture of things. They want us to explain how to find the sinusoidal function that models the depth in terms of time x. All that's really saying is you're going to have a function where x is your variable of time. Remember, for these sinusoidal graphs, which are sine or cosine, right? Sinusoidal functions doesn't mean just sine. It's sine and cosine. The x is the variable of time because if we're looking at some real life data, like this example, what we're really trying to find out is, okay, after 2 hours, how high is the tide? After 8 hours, how high is the tide? That's why x is the variable. Okay, so give yourself a chance to try this out. And here it is. They asked for an explanation. Well, I'm providing more than that, an explanation, a graph, and a function. If you want to just provide an explanation, that's just fine. Okay, low tide is 5, so that's the min. High tide is 83, so that's the max. We're talking about feet. I labeled that here, max and min. And we can use the max and min to find both A and M. Both of those equations only need those two inputs, max and min. So we put those in, we find the amplitude, we put those in, we find the midline. And since high tide occurs every 6 hours, the period is 6, right? We're saying, okay, how long does it take to go from max to max? That's what that's really saying. Okay, and we can use P to find B. Because ultimately they want us to explain how to find the function. So you're not just writing the function here, you're explaining how you're finding it. So I'm explaining, showing work, explaining, showing work. You will be asked to do some of this on your Part 2 test. Maybe not exactly like this question, but the idea of explaining and showing work. Okay, so we use our B formula because that's what we need in our function right here. We found P is 6, plug it in. There's our period, or sorry, there's our B value. There it is, plugged in. So we have A, we have B, we have M. Now to find out if it's sine or cosine, I really think you should draw a quick graph. It doesn't need to be as nice and neat as this, but you do want to kind of visualize what's happening. They're saying at 3 p.m. the water depth is 5 feet. And then, or yeah, right here. And then every 6 hours, so 6 hours later, we're going min to min. Okay. So when I'm writing out these times, I'm basically starting at noon. Okay. So the time, this is one way to think about it, because you might be wondering, and for a moment I was wondering, well, how do you know what the y-intercept is? How do you really know? Well, keep in mind, we're talking about time on the x-axis, right? So right here, it always has to be 0, right? So there it is. Let's look at number 12 to wrap this up. The table, we've worked with tables, and we will again right now, shows the height of a car on a Ferris wheel as it travels in a circular motion. If the car is loaded at 0 seconds, then the car is at its what? Highest or lowest height? What do you think? Well, Give an answer and maybe try the rest of these because this is what we have. It's at the lowest point, right? You are not climbing the Ferris wheel and getting off at the top, right? You're starting at the bottom before the ride starts so you can then go around the Ferris wheel, right? So it's loaded at 0 seconds. No time has started, right? You just got on the Ferris wheel right here. Okay, well, the car makes a complete revolution in how many seconds? Well, here is our seconds column, and we need to see how long it takes to go from the same value to the same value. So we see 5 here, and so we're looking for 5 again. We see it there, and we just want to make sure this pattern continues. So we go 5, 30, 55. Here, 5, 30, 55. There's no more information. It looks like we've identified the part of the pattern that repeats, which would be the period or the cycle. So it took 5 seconds, right? 0 to 5 seconds. The minimum height of the Ferris wheel is 5 meters. How do we know that? Well, it's the lowest value in the table, 5. And the height, the maximum height, is the highest value you see in the table, 55. And the radius, the distance from the middle of the circle to the outside, well, that's the radius, but that's also what we know as the amplitude. And we know the max and the min values, so we can use our amplitude equation to find the radius. Right. Excellent job. Do yourself a favor and study this practice test. Watch the recording to get any notes you missed and turn it in for points. And don't forget to use it while you take the Unit 1 test. Study, study, and you will succeed. See you later.